Alright, so in this video we're going to be looking at similar areas. This is going to build on all the similar shape stuff we've done previously, and now we're going to be dealing with identifying what the area is of an enlarged or reduced shape. So to begin with, as a little introduction, I'm going to show how we come about identifying the area scale factor and why we do what we do. So to begin with, let's look at question 1 here. So I've got two rectangles and we can see here my linear scale factor is 3 because 2 times 3 would give me 6, 4 times 3 gives me 12. So that's how much it's increased by. So what I'm going to do, I'm going to find the area of each of these. So because it's a rectangle, it's length times breadth. So I'm doing 2 times 4 there, which is 8. And over here for this one, it'll be 6 times the 12, which is going to be 72. And then I'm going to use the idea of my scale factor of new over old. And I can apply that same idea for my area scale factor. So I can still do that whole new over old, but using just the areas. And what I'm going to do, I'm just going to call my new shape, my larger shape there, the new one, and that's my old, sort of following the arrow where I'm going. So that's going to be 72 over 8. So that's going to give me 9. So that's my area scale factor. I'm going to come back to that in just a moment. I'm going to go on to question 2 here. So I'm going to do a similar thing to what I've just done. So here, my scale factor, 2 times the 5 would give me 10, and 4 times 5 would give me 20. So I'm going to find the area for both of these. So again, that smaller one is still 8. And for this one here, 10 times the 20, that's going to give me 200. So then, I'm going to do my area scale factor. So the new over old. So let's just make that smaller one again, my old one, and this one here, my new. So 200 divided by 8, I'm just going to use a calculator for that. And that's going to give me 25. Now, let's pay attention to how we go from our linear scale factor to our area scale factor. So for this one here, my scale factor was 3. And then my area scale factor was 9. Then for this one over here, my scale factor was 5. And then my area scale factor was 25. And essentially what I've done to go from my linear scale factor to my area, all I've done is square the thing. So 3 squared is 9, 5 squared is 25. And that's what I'm going to do for these questions. I'm going to square my linear scale factor to get to my area scale factor. So that's an important thing to remember. Area scale factor equals your scale factor squared. So what I've got 3 different types of questions that can be asked on this idea. So let's just get straight to it. So the first one is one of the more straightforward ones. The following pair of shapes are similar. Calculate the area of the larger shape. So I don't know the area for this one, so that's my new and that's my old. So the first thing I need to do is I need to find my linear scale factor because I don't have any information about the area one yet. So doing my new over old, that's going to be the 30 over 12 and that simplifies down to 5 over 2. So then my area scale factor, I'm going to take that scale factor and square it. So I'm doing 5 over 2 all squared. And that just comes out as 25 over 4. So then my new area, I take the area scale factor and I multiply it with the old area. So I take the area scale factor and I multiply it with the old area, which gives me an answer of 225 centimeters squared. And a good little clue that you are having to square the scale factor is the fact that in the units, we do deal with centimeters squared, meters squared, millimeters squared, and so forth. Okay, so the next type of example. This time, we are being asked, is the following pair of shapes similar? Or are the following pairs of shapes similar? So, I've got these two triangles here, and I want to prove whether or not they are similar. So what I'm going to do, I'm essentially going to ignore one of my areas, and I'm going to basically follow through my question as normal. Typically, I often make my new shape, quotation marks, whatever one is my larger one. So I'm going to pretend that this is a normal scale factor question. I'm just going to ignore that area for the time being. I'm going to pretend we don't know it and it doesn't exist. So I follow through, same like we did in the previous question. So doing my new over old. So now corresponding side, it's going to be the 12.4 over the 3.72. And I can put that in the calculator for it to simplify for me. And that comes to 10 over 3. So my area scale factor, taking my scale factor and squaring it. So the 10 over 3 squared, and that comes out to 100 over 9. So then my new area, I take that area scale factor and I times it with the old area, so that 4.56. And that comes out to 51.6 reoccurring, so it'll be 666 and so forth, which just rounds to 51.67 centimeters squared. So we expected to have this area here. However, we've come out with something different, which means they are not similar. And so now I need to write my statement. So I'd say, using the linear scale factor from the shapes does not give the area in the question. And I'd even do a little numerical comparison here. I'd use that 55.8 and I would say it's not equal to the 51.67. And I'd write, so they are not similar. So using the linear scale factor from the shapes does not give the area in the question. 55.8 does not equal 51.67, so they are not similar. So that's essentially what you do with these. You go through it as normal and you see if you end up with that area that is in your new one. Okay, last question type then. So this time, the following pair of triangles are similar. Find the missing length. So this time we know the area, but we don't know the length. So we can't do our linear scale factor because we have an unknown there. However, we can do our area scale factor. Because remember, it does work the same way. So we still do that new over old. So that's my x, so that's going to have the new. So that makes that one my old. So that's going to be 12 over 75. And 12 over 75 comes to 4 over 25. So then we need to figure out what our scale factor is. Now remember, our scale factor squared is the area scale factor. So if I wanted to just find out the scale factor using all my knowledge of changing the subject and solving equations, To get rid of that squared sign, I just need to square root it. So I need to square root that area scale factor. So I'm doing the square root of 4 over 25, and that would just be 2 over 5. Let's just make that 5 a little bit more clear. And now I have that scale factor, now I can find out x. So x is going to equal that 2 over 5 times by its corresponding side, which is 20. And so that would come out to 8, and that'd be 8 meters. So treating it pretty much the exact same, but all I have to do is square root that area scale factor in order to find out what the linear one is. Let me know if you have any questions, and good luck with the work.